Not the bad one.
It keeps it live audio while you move.
Can you go, Alan?
Hello, everyone. I expected an introduction from Francesca. I'm expecting that we are live.
Yeah, I think so.
Hello. Yeah, sorry, Alan. I had a technical issue, but I'm back. So welcome back, everyone, and welcome to this second part of the second day of the conference. Now Alan will host this very interesting panel session with very high technological level. So I leave in the microphone and I disappear again. Enjoy the session. Bye-bye.
Thank you, Francesca. And I think the most important word there was panel session, and the objective is to have an interactive Q&A. So please launch your question. This was conceived as a way to end the conference and maybe explore a little bit beyond our shores of pure digital permitting and explore the digital context of the built environment. Hence the title for this panel and the typical platformization hypothesis that I tend to share. And I've invited a couple of eminent panelists that I will introduce in a second. The context of the digitalization of the built environment is something that fascinates me. And just briefly, my points of reference are venture capital, where I operate, digital transformation as a strategy for the built environment, and some digital leadership that I provide at Buro Happold, but also the Construction Innovation Hub in the UK. And I think the really interesting motivator, I suppose, or point of departure is this idea that $165 billion are predicted to come into our industry. So yes, that's $165 billion of fresh capital that is predicted to be coming into our world to drive change. And you could see, for example, that just on the European theater, 1.5 billion euro was invested in 2018. So we can expect change, and we can see that maybe something is happening. And I think the best way to think about it is to think that BIM and GIS are really a new digital medium that is allowing us to really rethink about the built environment as something that has been digitalized. And then we can rethink from first principle how we use all that data and how we might be able to innovate or think about projects and fundamentally transform the industry. And really what we mean by that is if we think about that European invention that went on top of the internet called the World Wide Web, we started to think about that as a platform, and the first platform, and quick math is 32 years old, and nearly to the day. And when we started with it, that semantic linking of information across the internet that already existed was thought to be vague but exciting. This is the original patent, or certainly research grant application at CERN, and that vague but exciting comment is a true comment made by the supervisor of Tim Berners-Lee. The second platform that we now know as the social network, again, there is a patent dates back to 17th of January 2012, and we know it's rather exciting but also addictive. Launched in 2004. And then we're starting to talk about the third platform. Elon Musk saying, are we living in a simulation? It was on the cover of Wired, the mirror world. And now we're talking about the metaverse. Another way of talking about it, this is Forbes last year, about a year ago, about the next version of the internet. Is it called the magic verse, the cyberverse, the metaverse that would provide a digital agency of all of us onto the physical world. And in that context, we can see that what we've been talking about, digital permitting, is not going to happen in the old world, but it's happening in the new world. And we're seeing some really key trend around digital twinning, which is a concept of 2006, when Greaves start thinking about, how through this information mirroring model, you are able to manage assets better. So that's, quite a well-established concept in the literature now. We're seeing the gaming technology engine really scaling and scaling and scaling. And Unity and Unreal being those two, leader and View City having been built in those. And we have Paul with us from View City to share their experience. And then the cloud vendor invasion of our industry. We're seeing Oracle, we're seeing Azure, we're seeing Amazon, and a key partner of Azure and its translation to the built environment is Bentley Systems, and we're really really lucky to have Greg from Bentley Systems today. So that was the proposition. Let's explore the digital context in which digital permitting will happen. And we're really lucky to have Greg, and I know he won't talk about himself, so I'll do that for him for a few minutes, and similarly for Paul. So Greg now is the Director of Digital Innovation Lab at Bentley, and he will share what that means. But Greg is an architect by background, went and did a Master in Design Computation at MIT, and from there joined Revit, a small spun-out company in the Boston area, and that was acquired by a big company called Autodesk, and Greg continued as part of the Revit product group until 2012, and eventually escaped the Dark Lord. Is this being recorded? Yes, it is. No, we have many friends, and then joined a new startup. Having done 3D, it was logical to be 4D, so Synchro 4D. And that was acquired again in 2018 by Bentley. So I think a very fascinating perspective of working in startups and with giants of technology in the built environment. And Paul also accepted to join us. Paul is a product designer by training, and came from the visualization world and the gaming world, and was part of the founding team that thought, let's put our cities in the game engine. And now is CTO of View City, which is a city scale a city representation in the cloud of 20 cities in the UK so far. Part of the Inception program, leveraging Unity game engines and many other, and Paul will explain in a minute. So without further ado, what I'd like to do is invite Greg to talk maybe for 10-15 minutes about digital innovation labs and this digital context of our industry.
Okay, cool. Thanks, Alan. I'll just share my screen.
And while that's happening, please, shoot questions. We're here really as a panel and not so much as a delivery.
Cool. All right. So I trust you can see my PowerPoint at this point. And so thanks for the introduction, Alan. So yeah, my background does have this. I've kind of gone through from 3D to 4D into mixed reality. And now what I'm really going to talk about is transition into a platform, and what does a platform mean, and the technology that we're developing, which is a departure from just point solutions like Revit or Synchro to a platform technology that can solve this scale problem. What's emerging is this new target, this new idea of the digital twin, and I think what we'll see is that the digital twin has to be much more than files that you exchange. peer-to-peer. I start here just, if you're not familiar with Bentley Systems, Bentley Systems is traditionally a software and services company with a specific target on infrastructure market. So specific solutions that target like infrastructure, whether that's substations, cell phone towers, water utilities, power plants. That's sort of like the wheelhouse of Bentley. So most of the world's infrastructure is probably being designed and engineered with Bentley products. So it sort of sets the stage for sort of the market segment that Bentley targets. If you're familiar with tools like MicroStation, that's sort of like the core engineering platform that a lot of this is built on top of. But what I'm going to focus on is a new business model that Bentley is now entering into, which again is not about point solutions or engineering solutions. Now those still exist, but it's this shift into this digital twin economy and market, and how do you sort of serve this use case? And the belief here is that a platform is the way to do it. And so just to kind of situate this idea, the digital twin in a basic sense is that for any physical asset that exists in the world, there can now be a digital representation of that asset that can be tracked, monitored, and updated in near real time. So if you think about something that's manufactured, that's a physical thing. If you do a drone scan or a photogrammetry scan of that object and produce, like say, a photogrammetry mesh, that can be a digital twin of that object. And if you apply AI machine learning to that, you can start to do things like detect automatically defects or cracks from that digital asset based on the physical reality. And then from that, you could execute actions, maintenance requests or service requests. And all this content can now be experienced in a range of different experiences. I've got with me an example of one. Here's a head-mounted display. You can experience now these assets in a browser on a tablet. And what really enables that is that everything's running basically in the cloud these days. And when the data persistence is cloud, it means that you can then extend that information to a wide range of outputs, from a web browser to a HoloLens to a tablet. So that's really the shift, right? Is from files and sort of exchanging files to a live persistent data layer that can be accessed by a lot of people and through a lot of different devices. And so what the purpose of the platform, now I'm going to talk about platform versus product, is to say, what happens if you expose all these APIs in these cloud services to a wide range of startups, innovators, developers, and basically let the market determine what is the future of the digital twin. So rather than Bentley as a company trying to solve this problem and sell it to the market, what if you just expose all these APIs that are running on top of a cloud service layer? In this case, it's all running on Azure, but it could just as well be Amazon, and let the market basically take these tools and build solutions on top of it. So again, now that I'm talking about a platform rather than a product, these are the type of components, sort of APIs, that are available that you could build custom solutions on top of. So I'm not sure how familiar the audience is with all these ideas, but in a nutshell, what this enables you to do is import or federate a wide range of 3D models, whether it's a Revit model, a Navisworks model, a DGN, DWG, doesn't really matter, and also a wide range of reality modeling solutions, so point clouds, reality meshes, manage that on the back end in the web, and then serve that up through visualization, right? Essentially, this is what we call tile streaming graphics to a web browser to handle a scale problem, and then build applications on top of that. So what that looks like, and I'll show you a couple examples, could be anything from just 3D model verification at any scale to 4D construction simulations of how construction might be built. And when you get to operations, could be a connection to IoT sensor data lighting up issues in a floor plan, for example. And I'm also going to talk a little bit about AR, VR, the experience of this content on top of an actual lens. So the shift really, instead of engineering tools being, as a Bentley product, it could be any engineering tool, any format, ingest, exist in a web, and basically as a database that can then be fed out to any of these kind of users, project managers, BIM managers, inspectors. It's sort of like open to interpretation, and that the platform basically enables that. The construction of apps and user experiences that target specific users. So basically models are managed here, imported, federated, and then visualized and experienced by end users. Again, this is just services. What this looks like practically is sort of open-ended. This is just to point out a wide range of file formats that can be converted, and I think this is also important when you think about platforms moving forward. In no way is it going to be one file format in the future. The platform needs to be able to interchange a wide range of file formats back and forth between different systems. So import and export. So what this looks like, this is just one example, of a workflow. User would log in, right? So it's web-based. With the username and password, you can visualize large models, connect IoT data to those models, pop-up reports, icons, inspection details, and that user could then access things like documents, create a work request, and perform work. So this is just one example workflow that you could do. And I'm going to try and move through this very quickly. The other kind of platform that we're seeing changing is just the way, beyond just the web, it's the actual human-computer interaction, going beyond now just the mouse and the keyboard and a screen to a sensor that can detect human interactions in a very natural way. And so what this looks like now on top of this platform, and I want to show this just to get people thinking a bit outside the box here. What does it mean if you can take that content of the digital twin and go beyond just viewing it on a browser or a desktop and actually interact with it as a hologram at sort of any scale? And I think I'm running out of time here. And this is an example of a human interaction here. So what if you could actually see that digital twin and interact with it through a mixed reality heads-up display, and then start to rethink, how do you take measurements? How do you log issues? And everything that's done here is now just with your eyes and your hands. No keyboard and no mouse. So I think I'm at my 10 minutes.
That's absolutely fantastic. Share. I can see that's the office there. Is that the video taken through your headset?
Yeah, this is all being recorded through the headset, and now seeing that digital twin model, so it's a digital model aligned with physical space. And so now what you're experiencing here is I'm actually walking through the digital model while I'm walking through physical space, and it's a mixed reality headset, not a VR headset. You're still able to see your context, see your physical reality, but you see the digital model overlaid and digitally aligned with your physical space in stereo projection, project to your eyes, to your retinas, something called waveguides.
We'll come back to the question in a minute. They started coming in, and I propose we hand over to Paul to share his vision of a platform. I suspect with the word city in it.
Thank you as well, Greg. Is that money being streamed then? That's not running on the device. That's like being streamed into the.
That's all streaming off a cloud server. So that's GPU streaming to the HoloLens.
Yeah. Okay.
Thank you, Greg. That's been a fantastic first walkthrough.
Can you see that slideshow?
Yep.
Yeah. Okay, great. So hi, Paul Stankusi. Sorry, my name didn't come through properly, but yeah, I'm Paul Stankusi from VCity. And I'm going to start with a video, and I've got a couple of really short diagrams and a little bit narrative, then I'm going to jump into a live demo. So my slides aren't as pretty as Greg's, but I do my own graphics, and then I will do a live demo. So quickly, this introduction video, just talking about VCity.
We don't have your sound.
Audio's not coming. You might have to reshare and click. There's a checkbox to play system audio.
Sorry, say that again. Reshare.
Yeah, reshare. And I saw there's a little checkbox. I think it's the play system audio.
Okay, thank you, mate. Share audio. Yeah, I got it. Thanks, guys. I'll just rewind.
It's not working for me, I think, the audio, but I think it worked better without the audio, I think.
Yeah, it's the audio is getting really broken.
Sorry, Paul, maybe you can send me the video via email, and I will upload it in the platform so that maybe we can try to play it from here directly.
Yeah, I mean, it's just a spiel. I think it's just a good intro to some of the concepts. I can jump straight into the live demo and just skip over, that's fine. I'll let it play out because the subs are there and that's the content.
maybe you want to share some history of how the company came about.
Yeah, okay. So we were making visualizations, classic CGI renders and videos, and then we got into making interactive iPad and PC applications using game engines around 2008. And eventually we realized that we were making the same application over and over again, with like a small area of city context around each app. So we reached out to a company that were modeling London. We partnered with them and formed VCity. So it was basically a surveying company that was doing large area photogrammetry models, joining forces with my company, which was an app development and sort of digital communications company. So we were both already working in the real estate industry and in planning, and we basically applied our skills, the model and the app together to make VCity. And I've got a slide here which just talks about the life cycle a little bit of that. So you have your real world city with your politicians, your planners, and your citizens. We basically use photogrammetry to fly over cities to extract the 3D data. We're doing that with photogrammetry, and we're doing that very manually at the moment. We're not using any algorithmic capture. And it's not like a structure for motion model like you might see in Google Earth. It's like a rationalized, human rationalized model. We then obviously store that using Google Cloud Services. And then once you're into the real-time visualization, which is the Unity part, we're in the hands of the VCity users. They're able to sort of query, analyze, design, create presentations, collaborate. We've got a number of data APIs if people just want to access raw data. And we produce apps, like iPad apps and web apps on the platform as well for different use cases, like community engagement, for example. And that's the sharing piece, which ultimately ends up being presented back to decision makers and citizens, and then changes are made in the real world city through planning, which then we capture and it goes around again. So we kind of are in a closed loop where, because VCity is being used by some 80-something% of local authorities in London, and all the major schemes are now being assessed in VCity, the changes in the city are happening inside the platform. So in a way, if we've done our job correctly, we don't have to go and refly London to go and model it again, because any changes are happening already inside VCity. So it's kind of a self-fulfilling digital twin, being in the planning industry. That brings on to this kind of narrative I want to quickly spin us through before I go to the live demo, which is a kind of planning is boring narrative, which I guess was my perception coming into planning. And there's a lot of apathy around city planning and most people don't really engage with it. But the majority of people live in cities, 68% by 2050, according to the UN. So therefore, cities are the reality for most people. And planning is the version control for reality. And I quite like that phrase. It's like planning is like the Git. It's very broken, the planning system, but it's aiming to be as fluid and as digital as Git is for code changes. And I think the whole planning technology movement is kind of effectively aiming to be more and more like a version control system we might use for a code base. Therefore, planning shapes reality, and therefore the circular part of that is that planning shapes digital twins of reality. So if you want to get into the industry of building a digital twin of a city, it makes sense that you enter that planning because it's the source of any changes. And I think what ViewCity have done is we found that the planning use case we have is just an economic engine that drives ViewCity having the most up-to-date digital twin of any city that we've taken and modeled. So we've basically got an economic engine for keeping a digital twin of the city up to date. And what we're only really realizing now is that we can sell our sawdust. Like the planning use case is great, it pays the bills, it makes a profit, but there's all these other use cases that can spin out of having an up-to-date model of a city that we're sort of starting to unlock now. So I'm just going to jump to a live demo. Does this tab come over? Do you still see that tab, or has it jumped? Do I need to reshare a different tab? I need to reshare a different tab, sorry.
No, we're good.
Oh, you see it? Oh, sorry, right, it trapped my tab. Cool. So this is basically me logging into the cloud service. Just to explain, this is running in the browser. There's no tricks. I'm running this off of my Chromebook, which has not got a graphics card. One of the challenges of us putting this technology in the hands of local authority planners is the local authority planners aren't allowed to procure gaming laptops. So where we have hundreds of local authority planners using this, they're not able to buy hundreds of gaming laptops or hundreds of CAD workstations, where the architects maybe do. The local authorities don't. So we deliver this via cloud, and since we did that, the usage numbers have really taken off because there's now no technical limitations or barriers to just jumping in. Within seconds of someone taking a license, they can be in London spinning it around on like any device. I'm going to jump into our London scene, but you can see we've got Edinburgh and random little campuses that we work on, and there's 20 cities in the UK, but also we've modeled significant portions of Manhattan, Dubai, Paris, Berlin, Sydney. Yeah, so you can see the model loading now. We are loading per square kilometer tile. So we never load the whole city. We sort of load it in and out as the user moves around. We are modeling to this 15 centimeter level of detail at roofscape. So we have a lot of detail at roofscape because really the roof level of detail is what's most material in planning in terms of views and visibility and impacts. The facades we don't model, we just extrude them down to ground. And we don't have textures because of how we're capturing the data. And I guess while this might look lower fidelity than some of the structure from motion models like the reality capture from Bentley or the Google Maps kind of 3D models we might be used to seeing, the problem with those models is that they're produced algorithmically. So you get sort of trees merged into buildings, and it's not semantically segmented as well. So I can just go in here and start to interact with the scene. I can select this building and remove it. Whereas it's harder to do that with a sort of structure from motion model. Also, because a human being has modeled this model, when a human being models this wall here, they just go 1, 2, 3 floor, and they can rationalize that whole face into 4 vertexes, a very light mesh with a very high degree of accuracy. Whereas when an algorithm tries to do that, it would have to describe this face with hundreds of triangles to be able to achieve this level of precision. And therefore you wouldn't be able to load a very long range view because you'd have to load all those triangles in. So at the moment we haven't found a way to reach this level of accuracy and detail and optimization using an algorithmic approach. But we're obviously watching very closely what Bentley are doing in reality capture and all the other kind of model capture methods. And eventually we want to be model agnostic. So at the moment we only put our own models in, but we want in future to be able to support other models. So we can get into here and start creating stuff. Again, we don't want to solve generative design, and we've added this tool very simply, really not as a design tool, but as a constraints derivation tool. This is really to define what the envelope within which you can design is, rather than to define the design. So the architects and developers and planners are able to quickly box something up and then analyze the visibility of it. So we can jump down to eye level, some sort of key locations, I just turn away from this wall, and you can see that's the building I just put up in Trafalgar Square. Probably won't get planning for that one. But then we can start to make assessments on the daylighting, overshadowing. We can make it cloudy, and obviously because we're in London, we can make it rainy. But obviously that's fairly manual, checking the visibility, so we're able to run some sort of automatic analysis. So I'll just demo this one tool. Can run a visibility test against this scheme, where I can click on that scheme, set the resolution of my analysis, and calculate this ZTV. A ZTV is a zone of theoretical visibility. And what's quite exciting about this is you see the power of game engines. As Alain mentioned, game engines are kind of taking the AEC industry by storm. And we're actually leveraging the NVIDIA RTX hardware accelerated ray tracing, designed for putting pretty reflections into games so that so the water in the shoot 'em up looks nicer. But we're leveraging that ray tracing to do this visibility analysis. So through NVIDIA optics, we're able to do 2.4 billion ray casts per second. And when the developer working on it finally cracked it, we use it for visibility, but we also use it for daylight and sunlight analysis around windows. And he called me up, and he said, he's German, I won't do the accent, but he called me up and said, Paul, how many windows are there in London? Because he can literally run every window in London in a few hours. So the ray tracing and the game engine and the R&D budgets from gaming being applied to AEC are letting us run these sort of city scale analysis at speeds that previously were not possible. And this is just an example of a visibility study using that approach. So if I jump to eye level now again, at one of these boundary conditions here, and I look back to the building, I'm just going to turn off the trees. Trees aren't being assessed in this tool, so I'm going to turn them off so it's clearer. And you can see as I shimmy around, I'm in the red here, where I'm just seeing that red top of the building, and as I go to the blue areas, I'm seeing the ground floor. And this basically speeds up the scoping of a new development 1,000-fold, because they can really quickly understand how many stories they're allowed to build before they obstruct sort of historic views or significant views. Yeah, so that's the create tool.
So, Paul, yeah. Please continue, but we're starting to get some questions, so I'm going to start asking them.
Please do.
And I think that the first question was, which I think is highly relevant of where you are at the moment, and then I'll hand it over to Greg as well, is how much do you think is feasible for the current overall technology to achieve in terms of representing physical assets in a digital twin? To shorten the question, what can you represent? How much? You're showing a huge extent, but you don't have the facade. And earlier on,
it's a great question, I think. And I think I was going to touch on this for your presentation when you mentioned GIS and BIM. And I feel like we're basically trying to bridge the gap between GIS and BIM. GIS is scale, covers country scale, and BIM is like door handle level of detail, right? And so what city information modeling is, which is what we're trying to do, or city information management, is we're trying to bridge the gap between GIS and BIM. And really to get the door handle level of detail at city scale is a computer performance challenge, right? So what we're doing is we're using the game engine and the gaming industry R&D budgets, which is driving NVIDIA and driving Unity and Unreal, right? We're basically using the game engine R&D budget to bridge the gap between GIS.
Oh, we've lost Paul there. But I think the demo here shows that by choice, and it is his choice, Paul can do a city scale model at 15 centimeter semantic representation. Greg, earlier on you were showing a bridge and zooming right in there.
I wonder if I could share my screen. I want to kind of answer this question with just a video that a user posted on LinkedIn the other day. But I think I can't share my screen. What I wanted to mention is this. With photogrammetry today, you can get down to incredible levels of detail, millimeter. I ran a test actually the other week on a bridge section here in London, walking across I think it's like Blackfriars Bridge over there, just with my phone, with my iPhone. and producing a super detailed high resolution mesh. So it's really, I think it can scale. And the cool thing about this web browser technology, this multi-scaling photogrammetry mesh, like running on platforms like the iTwin viewer, or Cesium is another one, Unreal, is that as you zoom in, the mesh gains resolution. So this idea of scale actually starts to diminish thanks to this new technology of tile streaming through a web browser. So it's amazing. You can literally go from that. If we wanted to, we could take that. We could probably augment the View City rendering with a door handle eventually. You know, if you zoom into it, it's just a matter of time. Or the use case has to be there too.
So we're now mostly limited by the use case rather than the technology. Is what I'm hearing. Just right now, you were talking about photogrammetry, and we're talking about models, and then we're talking about digital twin. And there was a question here: what's the difference, if any, in your view, between a digital twin and a model?
Yeah, that's a good question. For me, I think the digital twin it's a model, but it's being, I think the vision updated by what's happening in reality. And so it's sort of like, you can almost think of the digital twin. If you look at this, imagine that there's a drone capturing this asset like this on a regular basis and then updating the status. So that's, in a nutshell, it's a live, continuously updated version of reality.
A model, I guess, is a digital twin at the lowest update latency, right? A model has an update latency of 1 update when the model is created, and then so it's technically a digital twin with an update latency of 1, you know?
Yeah.
And then as you have a more and more live connection, then it becomes more and more of a twin. It's like a temporal thing rather than an accuracy thing, right?
Yep.
Yeah, and I think that's a really important point that you introduced, this idea of update latency, because going back into, academia and references to digital twin, it's actually very clear that it's the establishment of the link between the physical asset and the digital asset that establishes the twin. So it's twinning. If you have no twinning, you don't have no twin. And then you introduce this concept of what's the relevant frequency of update, because the data that's not updated has zero value.
Mm-hmm.
You're right. Like the sensor in the office, like the fire sensor in the office needs an update latency of like milliseconds, right? But the planning use case, like we update the model once a week, you know, because planning is like real estate is big and slow and bits of concrete, and
So I think that's a great great question, and not a marketing question. And so I think it's very important that as leaders in the field, this group recognize that there is a well-defined proposition there, and it's the twinning and that frequency of twinning that's determining. A quick question: can you integrate climate data and scenarios for 2100? I suppose this is Paul. You please give us more than yes.
Yeah, so it's funny you mentioned that, because we presented, we were obviously pitching this thing to investors, and we pitched to a big, the head of future cities at a major pension fund, and he was like, stop, this isn't about planning, it's about insurance risk for flooding and the sustainability and resilience, and it's a much bigger industry, all this stuff. But I guess, again, we're very much in the planning use case, and planning in terms of impacts on air pollution and traffic. There are sustainability factors, but our focus is very much on planning data at the moment. But we are speaking to environmental consultancies and flood risk consultancies and those kind of people, but it's just something we haven't been able to focus on quite yet. But fascinated to be involved in that, definitely.
And I've got a question here just from Angelo in Italy, and the word citizens. And I think earlier on you mentioned that planning is boring, but it is a citizen topic. So here the built environment citizen is becoming the main value proposition. We need to think about the digital sovereignty and the human digital twin. So before going too deep, how much is the citizen going to be involved in the planning process?
Yeah, they're the third party that we target at View City. So there's the change maker, the developer and architect, the city planner, the decision maker, the gate, and then there's the citizen, which is supposed to all be happening for, right? And while we initially had to target the relationship between the developer and the planner to sort of establish ourselves, we're now looking to open up that data set to the public, and we're doing a pilot with the Royal Borough of Kensington and Chelsea, where we're basically, it's a technical challenge. How do you give the random population access to this very expensive 3D model with a very expensive GPU attached to it? We're using 360 images like Google Street View, basically. We're calling it Your View City or Your View, where the population can navigate the city using a Google Street View kind of interaction with 360 image tours. And it basically means there's no installation, no download. It runs on any device. Everyone's comfortable navigating Street View. You know, it's easy, just arrows moving around, and they can see and comment on schemes from anywhere. And that's in the pilot stage now. So we're looking to put this in the hands of View citizens as fast as we can. Yeah.
So
the biggest to apply to the private sector is by giving citizens the power. Yeah.
And Greg, I mean, at infrastructure scale, Bentley, you know, you very much recognized leader there, and you know, similar question, but this idea that the infrastructure is there for social outcomes, is that a responsibility that Bentley sees and like to participate in that conversation?
I think so. Well, I think it's an interesting question about what, you know, at what level does the public engage the creation of these models, the management of these models, the ability to kind of provide feedback to the model. Are citizens being tracked and observed and recorded in the context of the model? Like, I think the tag and trace experiment that happened here in London recently is sort of interesting, right? Where you were sort of voluntarily coming up to a QR code and positioning yourself in the city every time you went into a restaurant or a place of business. So, you know, what does it mean for that information to then get, you know, consumed by, say, in this case, I think it was the NHS, and then represented in the context of a digital twin? I think it's I mean, I'm just thinking out loud here about interesting use cases where could, like, public, you know, your information as a citizen makes sense in the context of a living, breathing digital twin. And it seems to me like this COVID example would be great. You could start to imagine not just climate data, but hotspots of where the virus could be trending. And so now you could just log into the view of the model and see where things are trending and happening, because people are contributing to that data. In this case, it was just a simple app running on a QR code scan, you know, offering up your location in your city. So what other kind of information could be surfaced? Like, I'm just thinking another one, when I was out scanning a section of the bridge the other day, what if my photos that I'm recording are recording defects to the city, and they get ingested into a system, and then an algorithm could start to find where are the most photos being taken, or where is a critical defect that's been offered up by the public to then be addressed. So I think there's a lot of opportunities for the public to participate in the creation of the digital twin, the maintenance of the digital twin, the interaction with the digital twin. I like the idea of it becoming something the public can access. I think it's great. I don't think it's something that Bentley would own. I think this is a platform that should be open. So I don't know if that answers the question.
No, absolutely. You know, I was listening and very much, I think, agreeing with you and thinking, you know, how this really unlocks a lot of opportunities. You have the defining issue of surveillance capitalism, and you know, it was really interesting that you were saying, you know, Bentley, we want to provide the technology, but you know, we have to be careful. I think that's what I was hearing, and in general, I think this opportunity to restate the conversation between the city, the citizens, and the planners, I think it is a defining moment. And certainly, when you know, I read about the metaverse and providing social agency, you know, this is, in terms of city, this is the most poignant social agency we can have. So I think it is transformational and maybe makes digital permitting, really a really, as you were pointing out earlier on, Paul, about, the rules, the planner is boring, but actually they're there to represent. We made the rules, so why can't we vote, and upvote a tweet, and the data layers, their environmental, their traffic. We know that City of London released data and City Mapper grew out of that. We see tweet data being mined. So I think we've only just scratched the surface.
Yeah, I mean, the GLA just released the PLD, like similar to the City Mapper stuff, that the GLA only just released a planning API for planning data. Before that, it was all siloed in PDFs, right? The data, we're only just reaching a level of maturity in planning, which you can build stuff on top of, kind of thing.
Yeah, I can tell you a use case I would love to see in that city planner. And I don't know, like there's a new development being planned over here by Shoreditch High Street. I think it's called like the Goodshed place. It's a huge planned development.
Very controversial.
Yeah, very controversial. How could you make that available for actual public engagement? Because right now you just see like a LinkedIn post from the mayor saying, okay, I've approved this thing, but then you dig deeper, you find there's a lot of community activism trying to raise a voice about this, and what's the real impact of that? And I walk by that location almost every day, and it's really hard to know like what will that impact be on Shoreditch, But if you look at the renderings from one perspective, it looks beautiful and perfect, and then from another perspective, it's going to destroy all the sun exposure to Shoreditch,
So we're very much in the planning use case here, and the questions are coming in. I think there's one here that's quite an interesting one around the governance of the planning, the digital twin, and will we only cover cities or only those that can pay? Earlier on, we had a question: do you view city cover any cities in Scotland? And I think that's two eyes of the question. So from your point of view, Paul, why are you in one city and not the other?
Yeah, then I saw that
question. What is your point of view on that governance?
The government's point. All right, so the two things. I'll start the first one. I saw that question about the country, and like we're trying to unlock value with a limited resource, and there's more value to unlock in cities, I guess, would be my answer, right? Like we sell licenses to city change makers and to decision makers, and there's more changes in cities to be tracked. So if we're selling the version control, then it makes sense that we focus that where the most change is. But there's some unique examples, like there's a golden triangle of distribution sheds. The biggest real estate company in England used to be an office company. And now the biggest real estate company in England is Segro, which of shed. They make Amazon distribution sheds and data centers, right? That's now the biggest real estate offering in England. And they don't work in cities. They work in the golden triangle between all the motorways. Right in the middle of England, there's this golden triangle, Lutterworth and Rugby around there. And we're thinking we might model a huge area of just farms, because it's likely that in the future that's going to be full of distribution sheds and data centers, and that's going to be the new kind of economy. So we are looking at modeling now empty green fields in advance of Segro needing to get planning to build more Amazon distribution sheds there. And we have modeled in Scotland. In terms of the model governance, it's a tricky one, I guess. England's quite comfortable with these public-private partnerships and letting the private markets kind of drive innovation, even in public utilities. You could argue that the city model is a public utility and therefore it should be publicly owned. But then there's also this thing of like, citizens don't make profit from property development, property developers do. So they should probably pay the levy on the cost of maintaining the city model. Like road users pay road tax. So like developers should pay the city model tax, But we're not there yet. It's complicated. The Greater London Authority don't use UCity because they'd give us a monopoly. So they're uncomfortable with it, So it's like we're trying to, all the local authorities do because they need it immediately to do planning, but those big organizations have to be more careful because technically that should be something that's in the public control, So it's an interesting debate. I flip-flop between the two, whether we should be nationalized or whether private industry is the one to unlock the value and it just needs to be regulated better, I guess. So it's
and the question is not new, right? I mean, when Google started indexing the internet so that people could find, it was a utility, and then in the end they said, we would make it a public service. Search is a public service paid by those that are trying to connect, the advertisers. So I think we are in that realm. In some countries like China, you don't index the internet because the local authority wants to control what you find. I think that's a very pertinent conversation, way beyond the technical. But when we are proposing to create a metaverse, certainly there's a very strong position taken by Epic, who couldn't be here today, around the fact that the model and the metaverse should be supported by blockchain. It should not be centralized. It should be generally accessible. And their view of the metaverse is that it is this internet of net neutrality worlds.
We made some big mistakes. We made some big mistakes in reality, right? We've ended up with this feudalist kind of hierarchical system, and we've got a chance in a metaverse to change that, right? We've got a chance to start again and make it egalitarian. And I guess we don't want to repeat the lessons of history that we made in our base reality, in our omniverse.
So I think the question about making a digital twin not just of the city but of the country is important, and you've partially answered it, Paul. But I'd like to ask Greg, because a city is defined by its infrastructure, and you're really working on that very strongly, I think. Mm-hmm. And do you see that having digital twin of whole cities and the National Digital Twin Initiative in the UK, for example, do you want to comment a little bit on where do you see that going?
Yeah, I think that's the ultimate vision or goal, is a totally connected digital version of the world. I'm thinking another one that's recent. I don't know if it relates to it, but have you seen that example called What Three Words? Yeah. Where it's like the entire Earth has basically been turned into these cells that then can be a storage of information. It's sort of accessible to everybody. But I think, because infrastructure is serving the public, eventually I think there has to be some digital infrastructure, just like we have pipes, sewers, electricity. And this is like a thread that we can all access and be part of, whether you're taxed or not. I feel like anyone should be able to log in and access it. And so I think eventually it has to become like the metaverse becomes another type of utility that's developed that we can all subscribe to and access, just like I said, like water, electricity. Now we have the internet.
Metaverse as a utility. We don't have much more time, but I see the question around AI. So it would be a remiss not to use those two letters. What do you see, Greg, would AI unlock in the context of digital twinning of cities and digital platforms?
It's a huge question. Very practically, this is what I'm experiencing. So AI, you could go deep into this, but for just like supervised learning, images are great. And what I find interesting about taking photos and producing photogrammetry of the digital twin, it's a perfect candidate for AI. It's very practical. You can say, okay, let's take a ton of images. Let's start to train those images with people that just mark things like exposed rebar, right? Cracks, something's broken. We have spray paint here. That stuff is very easy. And then you could very quickly apply AI ML to these digital twin captures to start just flagging common defects and start to automate when a crew needs to go fix something, and the inputs to this can be photos, can be CCTV, could be aerial photography. And there's already a lot of research and work that's been done in this space using computer vision, training photography to identify things. That's kind of like a very short-term practical example. I think bigger term, then you just start to look at, I'll let maybe Paul answer this one, but what if you say, here's a plot of land, and you just ask a question, give me a project, and you just speak your requirements with natural language, and then boom, the system just starts generating designs for you.
Yeah. We've got a research paper we're writing now called the National Urban Land Optimization Neural Network, because with UCity and with all this new development data we're getting, we basically got the training data set for property development, right? Like you don't even need to tell it what you want. It will tell you the optimum design for any plot, because once you can assess the city, the analytics at city scale, and you can do the data science, you can kind of derive the optimum solution for any given land parcel. And that's why I kind of talk about selling the sawdust. Like the planning use case we have is just the economic engine that gets us an up-to-date city model with all the attached data and semantic information. What you do with that up-to-date city model, like the implications are endless, right? And AI just accelerates that potential, I guess.
I think that's really, exciting to point out, right? Is that richness of the data set then allows machine learning to start, to start derive new insights that were not possible. So it's that generation of that data, and then it raises the question around, whether it is open data. I think Frank just mentioned, this idea of open data, because if the data is open, then machine learning algorithm can, for the public good, derive insights, and it's a huge topic, and then we can see, for the public good. Frank specifically refers to the dreadful accident in the UK where we had Grenfell, and we really, wish now that we would be able to instantly mine a national digital twin, or a connected set of twins hosted in all sorts of platforms to identify this risk, right?
We're doing that now. We're running height analysis for City of London boroughs with MHLG to find buildings at risk above 18 meters. But it's depressing because the data quality is so bad. When you want to contact the building at risk, and you go to company's house, and it's through like 3 different shell companies, and you can't actually find the building owner to tell them to do a risk assessment, right? Like when you have something like Grenfell, we have a moral imperative to find the data, and the Ordnance Survey just give you access to everything, and it's fine. When you get to the meat of it, you can't actually contact the person because it's hidden in an offshore company. It was quite a depressing revelation, to be honest. But yeah, we're trying.
So yeah, I think you're starting to really unlock fundamentally different use cases for a digital twin, and a different conversation, which is really interesting. I have a question here from you. There was an approach proposed in Catalonia for a mix of 3D city modeling, model checking, digital twin, building development checker to follow up the development of works. So I'm not sure exactly whether I imagine in our context we're talking about a low frequency, because of course we're seeing very high frequency use case of construction site being monitored minute by minute through visual processing of the image, so the digital twinning of the site. But if I'm understanding this question, do you see the digital twinner being a bit of a regulatory policeman? Go and find me all the people that have built things that they have not got a planning approval for. Is that a use case to you that has been raised to you? I mean, the digital policeman.
I mean, we talk to the police for different reasons. So that's all about line of sight and like security sense. But we haven't really spoken in terms of building control, though. That's an interesting use case. Not really. No, not personally. Building control stuff, not for me. So,
and Greg, do you know of any other type where you've got this kind of digital? This is my alarm saying that we should be wrapping up. But sort of forensic use of digital.
I think about this all the time. There's this film called Deja Vu. I don't know if it was Denzel Washington film. If you kind of like project that forward, it's a bit science. They have this like time machine moment where it shuts down the power grid every time they play back the digital twin. But imagine we don't have to shut down entire power grids in order to have a replay situation. This photogrammetry, laser capture, point cloud generation, real-time capture could be super cool. Like it's potentially feasible. And the stuff I'm looking at too with Microsoft Mesh is interesting, capturing people and making digital twins of even like a human who can teleport into a situation. So if you can now capture a person in full 360 and have a holographic interaction with somebody, who's to say you couldn't have a full-blown forensic reanalysis of a scene where you could just pop into a VR mixed reality scene and have the experience of time space, in full reality. That's where I think this kind of like interaction becomes so cool, because you're interacting with that content as a human in real one-to-one scale, moving through the digital twin. So, you could investigate a crime scene or an accident scene, as it happened. I don't know. That's
need to rewrite 12 Angry Men with MR.
Yeah.
So I'm gonna have to wrap it up, but before we do that, I just one more question to each of you. So, Greg, you've spoken very little about the Center for Digital Innovation at Bentley, which you lead. If any one of the participants or anyone for that matter wants to engage with the center, what should they do?
Well, if they want, as a starting point, they could write me directly, greg.demchak@bentley.com. You could also look up the iTwin Partner Program on the website. And so again, what we're targeting here are startups, innovators, developers who just want to start building solutions. So that's a starting point. But check out the place to look for this type of new tech is called iTwin Platform. Search on the web, you'll find information on that. Again, it's a difference from, it's not an engineering software here, it's really a development platform.
And same question to you, Paul. You've got 20-odd cities already modeled. Of course, you have an economic model for maintaining them, but is this a closed system? Is this yours, or are you also equally inviting innovators?
Yeah, we realize we can't solve generative design. We don't know anything about machine learning. We want partners in all of those fields. Like if anyone can collaborate and help, we realize that this problem can only be cracked as a group, right? As an ecosystem of partners. Like, we've already been looking at iTwin. Even like ViewCity could end up a product on iTwin eventually, right? Like, so yeah, it's totally open. I'll put the email addresses there and then my Twitter handle as well. But yeah, we're really open to collaboration. We've only got limited resources, but we'll talk to anyone, yeah. Well,
thank you very much, guys. I know there are more questions, and now they have your emails to follow up. I'll hand over back to Francesca, and thank you everyone for the amazing questions.
Thank you very much for a very interesting presentation and panel discussion. May I take advantage of my position for making one more question to you? So, from what I could understand from your perspectives and opinions, so digital twin with respect to a common model, for example, it's a matter of update, not of detail necessary, right?
Yes.
Okay, so
yes, detail is to match the use case, right? And detail that just it's depending on the use case, I guess, the level of detail.
Greg, do you want to add?
Yeah, and the detail could always be augmented. It could be that you have a low level of detail. Like, I think it's interesting. He's got in ViewCity highly detailed roofs, but at any point, in principle, you could start adding detail where it's necessary. Again, that's the use case. So it might be that somewhere in that building, someone is doing maintenance on a pump or an air handling unit, and at that point, maybe the digital twin gets augmented with high resolution. And I think in principle, it should be able to just aggregate and grow. And then you just have to solve sort of like basically read-write access permission issues.
Okay, that's
and just to add, a couple of data points. First, I'm always fascinated and really thankful to the academic world to think about things deeply and then publish them and then peer review them. The concept of digital twin is highly peer reviewed, and it is about the twinning. It is about the twinning. It's not about the physical or the digital. It's about the twinning.
Connection,
and so
right?
that connection defines the digital twin. And the second data point that we launched in the UK, the National Digital Twin Initiative. And what's really interesting is that NDT, the N increasingly is coming to this concept that is a networked digital twinning. So the idea is that different authorities, different participants are creating digital twins of different things. And then if we can network these things, then suddenly you are in the concept of having a railway going over a canal next to a telco tower.
Twindergarten, I call it. The Twindergarten.
There we go. And so it's that network digital twin rather than national digital twin gets that platform ecosystem to emerge.
I think this is very interesting to be pointed out in order really to clarify what is this concept of digital twin, which sometimes it's used in a...
Yeah, it's used too loosely, yeah.
Thank you very much for this. And really last one. Who do you think that would use the digital twin potential first, also in terms of available performance of machines and connections and so on? So who do you think will be the first stakeholders of this technology?
I think it goes highest value use case down, right? So the first people to do it probably aeronautics and like automotive, and now it's coming into real estate, like down the value, right? Eventually you'll have a digital twin of everything. I think you'll have a digital twin of everything in your house eventually, including yourself and your children and your pet, and you know, it will become ubiquitous. But I think it starts at the highest value use case and goes down basically.
Yeah, I would agree. I think aerospace has already done it. You know, I think Boeing did it already. I think with the 7, I think the Dreamliner was like digital twin. I don't know if they're tracking the plane now in reality, but aerospace, military always seems to be first, right? And then the public good, and then eventually probably even gets down to like into retail situations. You're right. Anything that you can acquire. In some ways, maybe we're close to having a digital twin, but not a digital model in terms of our consumer production. Like if I think about everything you can buy today, practically speaking, off Amazon, has a complete digital thread. It's got a barcode. It's tracked from the production to arriving at your house. So if there is really a digital twin maybe already, it just doesn't have its 3D version of it. So
I think it's a really insightful observation that that connection being so important. So it's the geospatial context of the information. I think that's very, as soon as it becomes networked, then what we are adding is that geospatial layer that we didn't have before, because we could track a transaction like a bottle of milk that you buy at the supermarket is the result of a digital twin, because as you have a membership card of that store, that attribute and that behavior that you have of buying milk in that store is added. So that, for example, their use case is if you go and buy milk at another store, they'll have the ability to not add a bottle of milk on the one where you normally buy it, because you've already bought it at another one, and they'll have the ability to say we need an extra one in that store because you chose to do something different today, and that can steer the whole supply chain. But we have no geospatial context of that, and so it's that geospatial layer that we are adding to that twinning dimension that is phenomenal and scary at the same time. So just to scare, as you arrive in Dubai, your laser scan, your iris scans, and that iris scan data is linked back to your credit card and your footfall inside the malls. So you have to choose where you live.
Yeah, and then AI pre-crime robots come and snatch you up.
I'm ready for that future. Take me there,
Okay.
I think it's a fascinating concept, the digital twin of yourself as well, like being able to share your private information at different layers of privacy with, like, rather than Google and Facebook and Amazon owning the digital twin of us, right? They own it. I think we're going to see that coming back to the ownership of the individual, and you release your information with the integrated parties that you trust at the right level,
Absolutely.
I think that's going to come about. That's a big market to crack, the individual twin.
Yeah, and back to that,
meta-human.
There's a question here about the scarce twin, and I think the scarce twin is actually answering the same question as Greg, right? It's about understanding what information you need to make a decision, and I go back to the game engine. The game engine guys were cognitively very astute in pulling into the screen and calculating into the screen only the information that determined playability and experience. So they understood that concept of the scarce twin. I don't want to render the full horizon of the city because it's computationally intensive and doesn't add to playability. So I create these horizon and requirement of information that I need to bring to the visual layer to make the game work. Things like that is really interesting to think, wow, these guys in the gaming world 30, 40 years ago, they already had understood a lot around decision-making, cognitive perception of information, and a fake reality. So the scarce twin, pull the data, control the data, don't release the data, avoid surveillance capitalism through that decimation and the like. Lots to learn.
Thank you very much. Very
Thank you. Thank you for the opportunity. Very cool.
Yeah.
So now
fantastic.
Yeah. Thank you. Now I call Jada on the stage as well, so that we can proceed to the concluding remarks. Thank you, Jada. I leave you the stage to present the results of the interactive activities, and then we are back. Thanks.
Yes, thank you, Francesca. So we are now at the closing part of these 2 days of workshop, and I want to show you the results of the interactive activities that we held during these 2 days and related with the development of a digital building permit maturity model. So okay, I just want to show you this slide that collects all the input that we received by your side. Here you can see the process requirements of our maturity model, the rules and requirements, and the technology requirements. So if we analyze the relevance, okay, we can say that I set these two limits, these two baseline. Under 3 is an insufficient, let's say. Under 3.5, it's not good. So over this limit, this orange limit, your feedbacks were good enough, let's say. So for relevance, you have said that all these requirements are relevant to achieve the process, technology, and rules and requirements ambitions. Accuracy, I think we have to work a little bit more on improve the accuracy of the statement for each of these requirements, especially in the field of process. I mean, as a result, they were more than sufficient, but not good in some cases. So we have for sure to improve in some fields. And for clarity, the situation is in the middle between that one for relevance and for the accuracy. So something is not very clear yet. There are not so clear in these two cases in particular. In the other, they are a good clarity, but of course we have field of improvement. And then, of course, I've collected your comments, which are very important, and these are the feedbacks for us to improve the maturity model and to deliver a useful tool for municipalities in order to support them in their path towards the digital building permit process. So from my side, it's all. If you want to contribute to a further discussion and insight on this digital building permit maturity model, you can contact us, of course, me or Francesca, and if you want, you can fill up this form, and then we will contact back in order to open, let's say, a group of discussion about this topic of digital building permit maturity model. However, it's all from my side. I want to thank you very much, of course, for your help, your support, your feedbacks, your comments. They were very important for us. And yeah, I think I'm done.
Thank you, Giada. Is there any question or comments that you would like to make to Giada, or maybe some comments you would like to share with respect to this maturity model, or in general for a digital building permit maturity model? You can still raise your hand and talk if you like. Well, it's also Friday afternoon, so I understand that it's not a priority, the maturity model, but of course, whether you would be interested in collaborating to shape it, you can also contact Giada afterwards and follow on this. So now I just would like to close this workshop. And thank you very much to all of you, to all the speakers, all the presenters, the chairs, and also to all the attendants. We could see a lot of progress. And I think that we can also see this collaboration that started with the EUnet4DBP, so that many solutions are at different levels with slightly different results, but going in the same direction and effectively. So thank you, everyone. Enjoy your weekend, and see you next time. Bye-bye.